Welcome to part 2 of the Wood and Wood Products lecture. Perhaps the biggest environmental concern with using lumber as a building material is the removal of habitat and resulting decrease in biodiversity. Plywood can be used as an alternative because it can easily cover a large surface area and it is also cheaper. But how do we get a tree into a 4-foot by 8-foot dimension? The sheets of plywood are made by rolling the log on a blade. The sheets are then stacked, pressed, and glued together, with the grain orientation alternating for each sheet. The problems with plywood are that it is not as strong as lumber and it contains harmful chemicals. Because plywood is weaker, plywood structures or products don't last as long and result in more waste. The glues and other additives do give the plywood some added strength, but the off-gassing is toxic. The chemicals in plywood are volatile organic compounds, or VOCs, and they are known irritants or carcinogens. Urea and formaldehyde are typically used in plywood, and they can cause mucous membrane irritation, sinus complications, or even cancer in the nose or throat at high exposure. VOCs are ubiquitous in our indoor environments. They are emitted from the building materials and also from other indoor items like furniture, picture frames, shelving, etc. This is of major concern for public health because people in industrialized nations, like the US, spend about 90% of their time indoors. The US Environmental Protection Agency monitors a number of chemicals that we come in contact with, and all except 2 of them are more prevalent inside homes and schools, which is where we spend most of our time, than outside. This has been known for decades. In 1982, the US Consumer Safety Commission voted to ban urea formaldehyde in foam insulation, but the ban was overturned in the courts. There is no clear regulation on formaldehyde levels. The trailers provided by the Federal Emergency Management Agency, FEMA, to Hurricane Katrina victims provided a test case. The catastrophe created a situation in which families were confined to conditions that researchers wouldn't legally be able to subject people to due to the health risk. Despite air quality testing by the Occupational Safety and Health Administration, or OSHA, that detected formaldehyde levels at FEMA trailer holding stations on the Gulf Coast as high as 5 parts per million, or 50 times the EPA's elevated level, FEMA claimed that the trailers were safe and decided not to conduct its own air quality testing. The conditions were optimal for high off-gassing. The climate is hot and humid, the building materials were all brand new, and mobile homes are small, enclosed spaces comprised mostly of plywood and other composite materials containing high levels of VOCs. After moving into the trailers provided by FEMA, many people immediately began complaining of health problems. Be sure to listen to the NPR story about Hurricane Katrina FEMA trailers as part of the lecture material. Veneer has the same issues as plywood. Because veneer has a nicely finished outer surface, many people believe they are buying solid wood. Although it may be advertised as solid wood, it is a cheaper alternative that is essentially plywood with a nicer look. Particle board is of even lesser quality and has the same issues as plywood, but is even weaker and has higher amounts of VOCs because of the greater proportion of glues and preservatives compared to wood chips or particles. As trees became less available for producing plywood in the mid-20th century, particle board was developed as a commercially available replacement. Although the production of particle board may allow for some recycling of wood waste products from sawmills, the quality is so poor that the furniture or cabinetry made of this material does not last very long. Outdoor structures exposed to the elements need to be resistant to rot. There are several tree species that are naturally resistant to rotting because they have tannins or chemicals that repel the decomposers or insects that would cause the rotting. Cedars and oaks are examples of trees that can be found growing around here. Wet areas like the Northwest or the rainforest also have rot-resistant tree species, including the redwoods that can be found in the temperate rainforest of North America, and tropical hardwoods like teak or mahogany. But these naturally rot-resistant tree species also became scarce after decades of overharvesting forests. Companies had to look for cheaper alternatives than these expensive tree species. They turned to pressure-treated wood. What does pressure-treated mean? Pressure-treated really means chemically treated. Cheaper wood could have the same rot resistance if it is injected with certain chemicals. In trying to find a solution to frequent mine collapses, an inventor found a way to chemically treat the wood beams that held up the walls and ceilings of the mines. It worked well for that situation because it saved miners' lives, and the miners weren't in physical contact with the chemicals that much. However, pressure-treated wood used for outdoor structures like benches, fences, decks, picnic tables, playgrounds, sheds, gazebos, etc., can present significant exposure of the chemicals. The most common chemical composition of pressure-treated wood had included three metals: chromium as a binding agent to combine copper, which is a fungicide, and arsenate, which is a pesticide. It was labeled CCA pressure-treated wood. The problem is that the chemicals are not bound to the wood, so they can leach out simply by touch or also when the rain washes them into the soil below or drains them into waterways. Chromium, and especially arsenic, are extremely toxic to humans. They can cause problems ranging from skin irritation to neurological damage to cancer. People are exposed when touching the pressure-treated wood, for example, when children play on a playset, when there is high inhalation exposure, such as in a production facility, or through working in contaminated soil or eating food grown in contaminated soil, or through water consumed from a contaminated well. The graph shows the results of a small study that evaluated arsenic levels in the soil of 5 different community parks. You can see that some parks had a lot more than others, but all parks had significantly higher levels than what is considered a safe level, 0.8 parts per million. 3 had well above the 3.7 part per million standard level for industrial sites, and the other 2 park sites were just below that level of contamination. Due to the prevalence of these materials in outdoor structures, it is likely that there are high levels in most areas that had these structures present. The U.S. Environmental Protection Agency did ban the use of arsenic as a pesticide because of its known toxicity, but there was an exception made for pressure-treated wood products. The wood industry claimed that they could not make their products without arsenic. The EPA then tried to regulate arsenic as a hazardous waste so that the companies would at least have to track, monitor, and dispose properly of the arsenic in the production process. But the industry claimed that it would be impossible to do that since sawdust is too difficult to contain. The EPA did not attempt further regulation, but did require that the companies inform consumers of the hazards that these wood products presented. The companies did not inform consumers, and CCA pressure-treated wood became widely used without most people being aware of the health risk it posed. Wood pressure-treated with CCA could be found nearly anywhere outdoor wooden structures were built. Many ordinances and building codes required that outdoor wooden structures be built with pressure-treated wood to safeguard against collapse or rot, so these chemicals leached throughout neighborhoods. A public awareness campaign finally resulted in the replacement of CCA with other, less toxic chemicals by the year 2003. Although the industry fought the transition to alternative, less toxic chemicals on the basis that it would be too difficult for them to produce that product under those standards, other countries had bans on CCA in place for decades. The same companies had even produced safer alternative outdoor wood products in those countries where CCA was banned, while continuing to use CCA in the US. Pressure-treated wood is a dangerous substance and should be handled with care, particularly if it contains CCA. Pressure-treated wood has a slightly different appearance than non-chemically treated, naturally rot-resistant woods. It is typically a greenish color rather than gray after exposure to the elements. CCA wood should never be burned because that would release concentrated toxic chemicals into the air. If it can be removed, it should be sent to a hazardous waste site for proper disposal. If it is in use, it should be adequately sealed or painted to reduce leaching out of the chemicals. There are alternative building materials or methods that will reduce toxicity and/or environmental impact. We unfortunately don't have time to go into them, but you may enjoy researching alternative technologies or approaches, like those that you see listed here. And that concludes the Wood and Wood Products lecture.